Welcome to SpiLLI, the world's first distributed AI inference library. Today, we'll guide you through installing and getting started with SpiLLI. Whether you're working with AI projects or just diving into NLP, SpiLLI provides a seamless, efficient way to bring language models to life. So, let's get started. To install SpiLLI, all you need is Python and pip set up on your machine. If you don't already have Python installed, check the link in the description for instructions. Once you have Python installed, we can open a terminal in the location containing your SpiLLI PEM file and type the following pip install command. For convenience, you can also copy and paste the command from SpiLLI's download page. Pip will now fetch and install the latest version of SpiLLI in your Python environment. Once the installation is complete, we can go ahead and start using SpiLLI for inference. To do so, create a new Python file and follow along with the following code. To get started, we import Spin from SpiLLI. Spin is the client we use to connect our local computer to host computers running the AI models that we will request to use. Once you have imported Spin, you can initialize a Spin client object and specify the location of your SpiLLI PEM file in the initialization argument. This file will be used by Spin to encrypt your data in transit over the internet to ensure data security, and thus is personalized to you and should not be shared with other people. Now that a Spin client is initialized, we can start requesting AI models that we would like to use. Let's start with a simple tiny llama model. We request the model using the Spin request method and specify the model name using a Python dictionary as shown here. We can then run inference using the model by calling the run method on the LLM model object returned to us by Spin. Here, we'll test the model with a simple system prompt telling the model to behave like a helpful AI programmer, and with a query that asks it to show us how to multiply two matrices in Python using NumPy. Once the model has processed the query, it will return the result, and we can view the response. Here we see the model teaching us how to use NumPy in Python using a stepwise explanation of the process. Well, congrats on your first use of distributed inference using Spin. Next, let's try out the slightly larger Llama 3 Instruct model. While we still have the old model available to run further queries on, we will for now demonstrate how you can initialize a second model object running in parallel to the first one. Having multiple models running in parallel like this is extremely useful when building scalable multi-agent AI systems, but we'll leave that to further videos covering more advanced usage of Spin. This time, we can specifically instruct the model to output the result as contiguous piece of code with comments and not a stepwise breakdown as before. For this, we repeat the same process, request the new model, and then run a query on the returned object. This model, due to its larger size, takes slightly longer to process the query, but is more proficient at following human instructions. SpiLLI thus also allows us to explore different models and their trade-offs for a task at hand. Once the new result is ready, we can observe the difference and see that the new model has indeed returned to us a well-formatted executable Python code. This is then followed by a stepwise explanation. In the next videos, we'll delve into building more advanced AI pipelines with Spin, so don't forget to like, share, and subscribe. In the meantime, have fun trying SpiLLI out for your projects, and let us know if you have any questions. SpiLLI runs AI models in peer-to-peer networks, simplifying inference and reducing costs, giving you the flexibility to experiment with AI models and see results fast. From generating text to building complex multi-agent systems, SpiLLI is designed to streamline your workflow.